Now, why have I done that? When I measure or test my steak, what will my data come out as? Joules? What did the probe the other day, did that give me joules? What did it give me? Degrees Celsius. That sounds like a unit for something that's not energy. So I need to get a relationship between whatever variable I'm changing and temperature. There's more than one temperature on this, isn't there?
Yes.
Some of them are constant though. One of them is definitely constant. One of them we can assume is constant, which is a wild assumption, but we can make it that assumption for ease sake. Which temperature is constant?
Temperature around the actual thing, the temperature.
Yep, so when we look at these two, right, what's T2 and T1 represent?
The initial temperature from the moment you heat it up to the final temperature.
T1 is the temperature of our steak. T2, temperature of the
Heat source.
barbecue. We assume that one stays constant. For the ease of your mathematics, I'm going to let you assume that T1 is also constant. If your assignment proves to provide false results, maybe think about that. What have I now got? Can I rearrange that equation to get a relationship between temperature, thickness or area, or mass if you're doing mass, and everything else is constant? Does the specific heat capacity change?
No.
Does the temperature, the time change? Does the thermal conductivity change? Depending on, if you're doing thickness, does your area change? Does the temperature of the barbecue change? Are we going to assume the temperature of the steak stays the same?
Yes.
Looks to me like you've got some pretty constant variables there. The mass will change, but the mass will change in a way that we can predict. I'm not going to give that hint away. If I was doing area, does the thickness change? It shouldn't.
Because you're only changing one dimension.
So what you want to get is a relationship between your variable. I'm going to assume, just to show you what I'm talking about here, let's say I was doing an experiment where I wanted to find the relationship between the thermal conductivity constant and my change in temperature. What am I trying to find? So what's my independent variable? What's the one that I'm changing? I'm changing this one, aren't I? So how do I get K by itself? Sorry, how do I get delta T by itself? Times both sides by? Times T divided by? What would the relationship be there? What would be the expected relationship? If I double my K value, what would I expect to happen to my temperature, change in temperature? By how much? Don't just get greater, by how much?
Proportionately to...
What's another name for proportional? Linear. K goes up. If it doubles, T doubles. If it triples, triples. If it halves, T halves. The time? Can't I times both sides by time?
Yeah.
If I'm keeping everything else constant, Nothing else is changing. Won't that show a linear increase?
Yes.
And this is going to lead me to my next point. If this